Alrighty, guys. So today we're going to go from the sixth grade ratio concept to seventh grade rates and unit rates concept. So a ratio and a rate really are very similar. Like an example of a rate that you guys have probably seen before is the amount of words you can type in a minute. That's a rate, right? It's a certain number and amount of time. The amount of miles I can travel, the miles per hour, right? That's a rate. More specifically, both of those examples I gave you actually are what I would call unit rates. So a unit rate, and I'm sharing my screen with you here, is a specific type of rate where we compare something to one, right? MPH, miles per hour, is the amount of miles that someone can travel in 1 hour going that speed, right? Or in this case, our first rate, I can tell you that a particular student types 115 and a half words in 2 minutes. Probably not the best example because I bet you guys half words doesn't count, but that's your math teacher not knowing any better. So if you can complete that in 2 minutes, the unit rate of that would be a certain number of words in 1 minute. Now, normally we don't say in 1 minute, you would probably just say words per minute. Right? So in order to determine that, and you guys will learn this, it really is just a division problem. In this case, we want words over minutes, words per minute. So I'm going to go ahead and set it up. 115 and a half over 2. I highly recommend labeling your setup until you get the hang of them, because what's hard is coming up with the words to back it if I don't tell you. So we'll do a lot more of those, obviously. 115 and a half divided by 2. So we have 57 and 7/500 words per minute, also called a GWAM, gross words per minute. Okay, so 4/5 of a burger in 10 minutes. So what we really want to know here is the portion of a burger per minute, right? That's important to us because that helps us figure out our setup. If I want to know the burger per minute, I know exactly how I divide just from my wording, right? So let's do burgers, 4/5 over minutes, which is 10. Now, I used to do a whole separate day on complex fraction unit rates, and I may still do that, but you guys hopefully feel really good with that calculator, right? 4/5 is our division problem, 4 divided by 5. Then we take that number and divide it by 10. Now, if I wrote down that you ate that portion of a burger per minute, that's kind of weird. I don't think anyone would ever use that vocabulary, right? I ate 8/100 of a burger per minute. You probably would say 8% of a burger per minute. So we're going to talk through this chapter about just what are the reasonable types of rates you would have to. All right, last one, 12 pages in 2 3/4 minutes, or 2.75 minutes. So we're going to do pages per minute. So they're all minutes, and they're all minutes on bottom. 12 over 2.75. Get 4.36 repeating. Pages per minute. Must be a children's book, unless you're reading too fast. Let's see, I'm going to bounce down to the bottom here. I've been doing that a lot lately, but so here are some different brands of cereals, right? Cereals, I think. Did you even tell me? Yeah. Oh, there's syrup, excuse me. 4 different brands of syrup to choose from. And I'm going to leave that in there. I'm not going to edit it out. The chart shows the price that you're paying and the amount of ounces that you get. So what we're going to do is we're going to rank the brands from worst to best unit price. So I threw out the word unit price on day one because when it comes to the best unit rate for things that we buy, it really comes down to cost, right? If I'm going to buy a certain amount of syrup, I want to make sure I'm paying the least dollar per ounce. That's what's most important to me as a consumer. So it's all about the price. So we're going to set it up. I want to set it out to the side of dollars per ounce. Dollars per ounce. And we really are going to do each one dollars divided by ounces. I'm going to put the division symbol up here so we don't forget that. Here we go. $7.04 divided by 32 ounces tells me that I'm paying 22 cents per ounce. That's not too bad. Right? $4.80 divided by 20 ounces. I'm paying 24 cents an ounce. Already, I know that the golden syrup is better than the brown gold. All right, next one, $5.52 divided by 24. So this one is 23 cents an ounce. And last but not least, we have Aunt Mabel's is 26 cents an ounce. So according to our unit rates here, or unit prices, golden syrup is the best for us as the consumer because it is the cheapest per ounce. And I know you can create the argument like, well, what's a penny really do, right? But I actually tested this when I was in college because my mom gave me a certain amount of money for food each week when I was in college. Now I had the go eat in the food court situation, but then she gave me a food allowance so I could go out, Bradco or Jack in the Box or whatever, Taco Bell. Went to Taco Bell like every night. And so I literally went to the grocery store and thought, I want to see what difference does it make if I buy those name brand items versus the off-brand items. So I literally made a list of like my normal groceries. But the 1 week I bought Coca-Cola, or let's say Dr. Pepper. And then the next week I bought Dr. Vess, right? Or instead of buying I can't really think of a really fancy pasta sauce, but I'm thinking like down the hill, right? Like you can find some in Schnucks that are from the hill. They're like $9 a jar of pasta sauce, or there's the Schnucks off-brand pasta sauce. Of course, everyone has their preference on like, isn't that product maybe made with better ingredients? So let's try and not make that argument. Like, of course, I like Cheez-Its better than the off-brand. You guys, well, maybe my virtual kids don't know how obsessed I am with Cheez-Its yet, but you can always create that argument, but it's always about the lowest cost for us. And I'm telling you, it made like, I forget what it was exactly. I literally did a project on it in college, but it was probably like a $40 difference just by switching the brand to something that wasn't name brand, right? It's kind of interesting. Okay. So next thing we're going to do is make a decision with unit rates. Okay. So this question is about whose coffee is creamier, Mr. Odin or mine? Miss Moore uses 3 ounces of creamer in her 8.5 ounces of coffee. And Mr. Odin uses 4.5 ounces of creamer in 10 ounces of coffee. Who has the creamiest coffee? So if we're looking for the creamiest coffee, we want the greater amount of cream per ounce of coffee, right? And these are cream ounces over coffee ounces. The person with the creamiest coffee would be the more ounce of creamer per ounce of coffee, right? So there's our setup here. Notice how I did that for every problem so far. I kind of wrote my setup out to the side. I think that's really important. Look at Ms. Mort's and Mr. Odin's. Ms. Mort, I'm going to do 3 ounces of creamer over 8.5 ounces of coffee, and then 4.5 ounces of creamer over 10 ounces of coffee. Okay. The setup's the hard part, right? Now we just have to divide. Oof. So a little under, well, kind of way under 1/2 ounce of creamer per ounce of coffee. Okay. So 4.5 divided by 10. So we have 0.45 ounces creamer per ounce of coffee. So Mr. Odin has more creamer in 1 ounce of coffee than I do. Therefore, Mr. Odin has the creamiest coffee. I need my coffee strong. He actually does have his creamier. His coffee is creamier than mine. It's not a made up. I don't know. Does that real ounces? He actually does measure it though. Okay. All right. So what we're going to do together, and I will do one of these with you now and save 3 for our live meeting, is you're going to determine using unit rates if something is fair. And I think you guys are really good at this as kids, as teenagers. I know I was like, I got to do, or my brother got to do something. I had to be able to do it too. That's not fair, right? Well, here's some ways that you can mathematically prove if things are or aren't fair, okay? I'm going to zoom in on this first one. Let's say you pay $15 for 6 energy drinks. I pay $25 for 10 of those same energy drinks. Is that fair? So what I think would be helpful is to know the dollars per drink that each person is paying. So I'm going to do dollars over drinks. There's my little setup. Okay. 15 over 6. And I'll do another one on this side, 25 over 10. And let's see what those equal. Dollars divided by drinks. So you are paying $2.50 per drink. Yeah, that on there. Per drink. Give myself some more room. Over here, 25 divided by 10. Also paying $2.50 per drink. So this situation is fair. Yes, it is fair. There will be some situations that you look at that are not fair and some that are, and it's your job to determine which is which, okay? So I will let you pause there. I do have to unshare my screen to close the video, but I will see you in a little bit for our live meeting.